So good afternoon, students. So this is our fourth experiment, so in which we are going to see about signal conditioning. So in that there are two topics. One is analog to digital converter, another one is digital to analog converter. So the example for analog to digital conversion is, so there are voice recognized systems in which the analog signals are converted into digital signals, or else if we are taking microphone and speaker arrangement, whatever analog signal what we are giving, that is our voice, is converted into digital signal and it is amplified, and then again the digital is converted into analog signals and it is the output is received from the speaker. So that is an example for analog to digital conversion and digital to analog conversion. Okay, so this is the basic circuit for analog to digital converter. So here the basic circuit consists of 7404 ICs and which it is converted to the flip-flop arrangement. So this circuit is used to convert analog to digital conversions. So the analog to digital conversion is taken by taking sampling rates at a particular interval and converting that sampling rate into its equivalent 0 or 1 digital discrete values. Okay, so now let us, this is the kit for initially this is the kit for digital to analog conversion. So here there is an 8-bit kit in which we are having 8 switches. So currently all the switches is in off condition, that is we are having 0 as output, that is 0 0 0 0 0 0 0 0. So all the 8 bits are, it is counted as off position. So we are getting output as I will show you the output. So the output what you are getting is minus 6.42 when all the switches are in 0 conditions. Okay, so I am taking output here, and this is the basic circuit which is used to give analog input to this, digital input to this circuit, and this switches are used to choose the channels. Okay, so the output is minus 6.2, and if all switches are in on condition, if I am turning on all the switches 1 2 3 4 5 6 7 and 8, okay, if I am turning on all the switches, so if I am checking the output, so the output value is, it is plus 4.69. So the minimum output for all zeros, my output is minus 4.64, and for all ones the output is 4 plus 4.70. Okay, so now I'm going to turn on, I will be giving different inputs as given in this tabulation. Like if I am giving 0 0 0 1 0 1 1 0 0, that is I'm going to turn on the third switch and fifth and sixth switch. Okay, now all switches in, I'm going to turn off all switches. I'm going to turn on third switch and fifth and sixth switch. Okay, so for this condition, the output what I am going to get is, that is, so minus 3.06. The output varies like that for each different input, different analog, different digital inputs. The output will continuously, it will vary, and it is noted on the tabulation as like that. Okay, so this is the practical output voltage, and this is the binary input what we are going to give, and the corresponding theoretical output is calculated like this. So whatever switches, so everything is mentioned in 2 power minus 1 minus 2 up to minus 2 power minus 8. So if I am giving the input as V11001011, then whatever coefficients it is become 1, then I need to substitute the value, and remaining value is 0. I will not consider that. So for this connection, for this binary input, I am getting an output voltage of 3.18. So like that we can do theoretical calculation also. So this is the graph in which you are drawing between the hexadecimal equivalent, which is calculated like this, and its practical output voltage. So what you are getting, so you'll be getting a different curve. So if you are taking the nominal value, so you will be getting a linear output here. This is for digital to analog conversion. So now next we are going to move for analog to digital conversion. So for that, let me replace the kit with analog to digital conversion. So here, so this is the tabulation and circuit for analog to digital conversion. So this is of ladder type, and with a summing point. So by connecting each switch, there are 3 switches to connect signals, and initially we are going to choose the switches as, so like this we are going to choose as 0 1 1. So by choosing this 0 1 1, I am going to select a particular channel, so whose input is given by this particular kit. Okay, so by converting this digital, by converting this analog value into digital output, which is measured using my multimeter. So the output is taken like this. So for this I'm going to measure an voltage of 0.89, and I am having one start off conversion switch. By pressing this, so the conversion point it is getting started, and I am going to measure the voltages, so 0.87. So like that, for different channels I will be getting different outputs, the values are recorded. Okay, so when it comes to calculation for this, and this is how the analog input is given, and binary data output is received based on this following voltage. Okay, so for each voltage I will be getting one binary data output, and I will be noting that value, and the graph is plotted. So thank you. The basic application of analog to digital and digital to analog conversion is, the ideal example is microphone. So in microphones, the voice signal is analog signal. It is initially converted into digital signal, and then this digital signal is amplified, and then again converted into analog signal. Using digital to analog converter, it is converted into analog signal, and we are getting outputted speakers. Thank you, students. Thank you.